Hello and welcome to a new video, and in this one we are going to make Pong. Basic Pong, retro Pong, whatever you want to call it, just bog standard Pong. So the first thing we need is a ball, and well actually no, what we want to do first is we want to switch to orthographic, because obviously Pong is 2D, and we want this to be in 2D as well, and we're going to switch this to solid color, and we want it to be black. And the next thing we're going to do is bring in our ball. So our ball is going to be a 2D sprite, it's going to be a circle, and that's pretty much all there is to it. We'll just call it ball. And we're going to add a 2D box collider. Make sure it's 2D because it won't work otherwise. And we also need a rigid body because otherwise it won't detect any of the collisions. We're not going to be using the rigid body for acceleration or anything like that because we're doing bog standard retro Pong, but you do need it for the colliders. So we want to leave simulated on, but we want to turn gravity scale off. We're not going to be applying gravity to it. I'm just going to freeze rotation, although I don't think it makes a difference for what we're doing. And we want it to be on continuous. So the next thing we need is some walls because we need to be able to interact with something. So let's go back up to here and we're going to grab a square. I'm going to call this one bottom, and the naming of this is important. It doesn't have to be what I name them, but it needs to be, you need to have the name right because you're going to be needing this in the code. Let's just stretch that out to cover the entire bottom. I'm not going to worry too much about getting everything in the exact perfect position because it's just a silly game. We're not doing anything too serious. It ain't that deep, bro. Okay, we'll do with that. And then I'll copy that and drag another one up here. And then we'll duplicate again. And this one will make right. And then finally left. And the one thing that I didn't do that I should have done before I copied them was add a box collider. So let's get a 2D box collider on there. We don't need to do anything with the box collider. We don't need to do anything with the tags. The name is going to be the thing that's important. So let's, well, actually, first off, I'm just going to make that ball a bit smaller. So it's a bit on the large side. That looks okay. Right, so we're going to create a new script. And we're going to call it Pong Ball. We'll drag it onto our ball and let's open that up. First thing we're going to do is create a public float for speed. Just say it to equal 1 by default. We'll change that later. And then we need a vector 3. It doesn't need to be public, but this is going to be the velocity of the ball. And then we're going to need 4 balls. These don't need to be public, but I'm going to make them public so we can see what's going on with them. And they're going to be right, left, up, and down. So let's explain what's going to happen first. So the thing about original Pong is that the ball only ever moves at 45-degree angles. So if I just grab our ball there, if I just grab the ball and show you what it does. So this is going to be moving at a 45-degree angle like this. I'll just get a bit closer to the wall here. It's going to be moving at a 45-degree angle like this. When it hits this, it's going to rebound at another 45-degree angle. So it's going up and right. It's going to go, because it's hit a wall to the right, it's going to go up and left. And when it hits the roof, it's going to go down and left. And when it hits this, it's going to go up and left. When it hits this, it's going to go right and up, etc. It's always 45-degree angles. So the first thing we're going to do is get this ball bouncing around. You've probably seen this in screensavers and stuff. It's one of the first things a lot of people code is a bouncing ball. So we'll get the ball bouncing around at 45-degree angles. So let's go back to our code, create an update loop, and we will call a update velocity function that we're about to write. And then we will set the position. So we're just going to do this by doing transform.position plus equals velocity times time.delta time. And yes, you would do this in the physics update loop. You'll probably do it using the physics if you were going to be, you know, all proper about it. But screw that, man. So let's make our update velocity function. And essentially, this is going to check these bulls up here. And these bulls are representing which way it's currently going. So if it's going, it's always going to be going 2 because it's always 45 degrees. So it's always going to be going right and up or down and left or right and down, or etc. It's never going to be going left and right, obviously, and it's never going up and down because, well, that would be stationary. So I'll say if right and up velocity equals new vector 3, and then so going right is 1 on the x-axis, going up is 1 on the y-axis, and then we're never going to be doing anything with z because we're working in 2D here. And then we want to multiply that by ball speed, not ball speed, sorry, speed. And then we will copy all of that just to save a bit of typing. And then we need 2 more. We've only got 4 directions we can go in. So this one wants to be right and down. This one wants to be left and up. And then this one wants to be left and down. And then this one is going to be going to the right but down. This one's going to be going to the left but up. And this one's going to be going to the left but down. So -1 on the x-axis, -1 on the y-axis. So nothing's going to work yet, but if we give it a start velocity, so let's say right and up. No, we'll go left and down. If we give it a left and down start velocity and press play, our ball should disappear. There he goes. We'll need to make that ball a bit faster, I think. But obviously it gets screwy when it hits something because we haven't told it what to do on collision. So first off, let's just make this a bit faster. Now let's go back into our code and we need to create an on collision. So on collision, and make sure you get the 2D one, because that's something I do on a regular basis, is forget to do the 2D one. And we're going to get a value out of our collider, out of the thing we've hit, and it's just going to be called side. It's telling us which side we've hit. And it's going to equal collision.transform.name. That's simple. So then we'll say if side is equal to top, and we also want to say and up. And the reason we want to do this is because Unity doesn't always detect the collision the instant it collides. Sometimes it will detect the collision when it's overlapped a bit, and then we're going to tell it to bounce in the other direction, but in the next frame it might not have got all the way out of that collision. So we don't want it to register the same collision twice. So what we want to do is check, say it's hit the top and we are moving upwards. Because if it's hit the top and we're moving downwards, that means that probably the last frame we already registered that collision and we've already told the ball to start going downwards. So if it hits the top and it's currently going up, then we're going to say up equals false and down equals true. And then we can just copy that 3 more times and change everything. So this one's going to be bottom, and again we want to make sure that we are heading down when we collide with that. This one's going to be right, and once again make sure we're heading right. And then finally left and left. So for these, we'll change this one. We're going to set down to false and up to true. And then here we're going to set right to false, left to true, and then left to false and right to true. So now, because we've named these top, right, bottom, left, hopefully we've named them right, otherwise this is going to look weird. When it hits the walls, it should rebound. There we go. That actually worked better than I thought it was going to do. So we want some paddles. For now, I'm just going to have one control both paddles because there's only one of me here. So first off, let's just copy our left paddle for now, our left wall even, and we will call this left paddle. We'll just drag it this way, and we want to make it 0.4, 0.3, that looks, let's go 0.3. 0.3 looks all right. And 1, 2, 1.5. There we go, 1.75. Okay, so once again, I'm only going to give it the one control for both paddles. So we'll just get this paddle working, and then we'll just stick the same, we'll just duplicate it basically. So let us create a new script called Pong paddle. Drag that onto our Pong paddle, open that up. Dead simple to start with. All we're going to do is say transform.position. It's actually, we need a speed value for this as well. Public float speed equals, and once again, we'll just put it to 1F by default. Transform.position plus equals vector3.up times, and then we're going to get input dot get axis raw vertical, and then we're going to times that by speed, and then finally that by time dot delta time. There we go. We can move our thingamajigger. Of course, it doesn't work properly yet because we've called it left paddle. So we'll need to do something with that. Well, actually, you know what we can do? We can just call it left. So we know it's the paddle, but for now, if we just call it left, that will actually make it work. There we go. It's going to get screwy if we somehow manage to let the ball get behind the paddle, but let's see if we can do that. Yeah, see, it goes a bit weird if it hits anything other than the front of the paddle, but you get the idea. I mean, you can add extra colliders around there. I'm not trying to make this video too complicated. So the other thing we're going to want to do is we're going to want to stop the paddle from disappearing off the edge of the screen. So well, first off, let's just make that bigger. Make the speed value bigger. So you can see it can go off the edge of the screen at the minute, which is not ideal. So the way we'll deal with this is instead of getting vector3.up, we'll set a new value, say float move y equals, and then it's just going to equal this. And then we'll have another float, which will be called new y, and that's going to equal transform.position.y plus move y. And then we will have a max and a minimum. So our public float min y, public float max y. And then we can say if new y is greater than max y, new y equals max y. You can also use clamp command for this. Else if new y is less than min y, new y equals min y. And then finally transform.position equals new vector3 transform.position.x, new y, and then 0f because we're not doing anything on the z-axis. So if we go back in here, and let's just establish what our minimums and maximums are. So that is, let's say 4.8. So max y, 4.8, min y, minus 2.75. Then we'll drag that back to the middle and give that a go. There we go. And then we can just duplicate this, drag him over there. Where did we put this? Let's just move this a little bit. 7.5? Yeah, 7.5 and 1. And then this one is going to be 7.5 without the minus and 1. And obviously we need to call this one right, otherwise the ball's going to try and go in the wrong direction when it hits it. Bleep. 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 Sound effects are optional. So what we can do now is a scoring system. So what we're going to do is we are going to rename our paddle so that it actually says paddle. And the reason for that is we're going to make a slightly different command for what happens when it hits the wall to when it hits the paddle. So back into our pong ball bit, and we're going to copy right and left, and these are going to be slightly different. So basically the way things happen now, that's what we want to happen if we hit the paddle. However, if we hit the wall, we want to also implement the score. So because this is getting a bit longer, let's just break these brackets out a bit more so it's a bit easier to read. And then also we're going to need a score. So let's have public int p1 score, public int p2 score. And then so if we hit the right, so player 2 is on the right. So if we hit the right, we want to do p1 score plus plus. And then if we hit the left, P2 score plus plus. So now we need to make the scores actually show up. So I'm just going to go grab an appropriate font for this. Let's create as a UI element, which is going to be, we're just going to use regular text. We don't need anything fancy for this. So this is going to be score, and we want it to be, well, first off, we want it to be our other font. And then just so we can see what it looks like, let's put 0 and 0. I know it's not the exact Pong font, but it's close enough. Actually, these are 0, 0, and 0, 0, aren't they? Put 2 spaces. Is that 3 spaces? Yeah, 3 spaces. We will make it so it's fully stretched, and then we want it centered and at the top where it is, but we also want to give it a bit of a margin. So at the top, let's say 25. And I'm not going to make it pure white because the ball's going to be going over the front of it. I know original Pong had to do that, but original Pong, you know, had limitations that we don't have. So let's just make it kind of gray, and then back into our code, and we need to bring in a reference to this. So let's say public, oh sorry, before we can do that, we need to bring in the UI system. So public text, we'll just call it score, and then we'll do another function down here, void update score, which we will call like we called the other one. Well, actually we'll call this at the end after we've finished moving and everything. And then we'll say score.text equals, and then it's p1 score dot toString plus 3 spaces plus p2 score dot toString. And then to get that leading 0, we're going to do this. I think I'm right on this one. We'll find out in a second. Anyway, we're going to have to drag a reference to our score into our ball script. There we go. And I'm just, for the sake of appearances, I'm just going to duplicate this, call it center divide or something, or center will do. Remove the box collider, smack it in the middle, make it half the size, and make it a different color. Just going to give this an extra space. So that, I believe, will be it. Let's try it out. Okay, sorry, I'll just switch this canvas to scale with screen size. There we go. And we have Pong. Very basic Pong, but we have Pong. So that is it for this video. I hope it was of use to some of you, and if not, of vague interest to others. All that's left to do now is to thank my amazing Patreons, and the special thanks as always go to the Sugar Daddy / Mama tier supporters, who are Dave Maldine, Reg Reed, Gabriel White, Aaron Clark, Mr. Drunken Dragon, and Julian. And that is it for this video, and I will see you soon with another video. Thanks for watching. Bye bye.